Throughout your programs, you need to declare constant values. These constants are used to assign to variables and used in arithmetic statements. The normal way to declare a constant is to just type in a base 10 number, but there are other things you can do, and sometimes these other ways make more sense, depending on the source and the meaning of the data. You've already seen all the possible values of the Boolean data type. It can either be true or false, and that's all. A byte is a signed integer. You can assign a value to it as a simple base 10 number, like one of these. In Java, you can declare a hexadecimal value by beginning a number with a 0 and the letter X. All of these are valid hexadecimal numbers and will fit into an 8-bit byte. Now, if you want to set the first bit of a hexadecimal byte value, which will make it a negative number, you'll need to cast it like this. One more, you can specify a byte value in octal digits this way. Any number that begins with a 0 is taken to be octal. Once again, if you specify a value that has the first bit set, you'll have to cast it to the right type. In this example, each digit represents 3 bits, so the rightmost 3 digits cover the whole 8 bits of a byte. The number 7 is 111, and the number 3 is the value of the leftmost 2 bits, which is 11. A short is also a signed integer. You could use any of the base 10 numbers to specify a short value, and you can use hexadecimal literals in the same way that you can use with a byte. Again, if you specify a hexadecimal number that results in a negative value, you'll have to cast it to the right type. You see, Java interprets the literal as an int value and won't store it in a short unless you specifically cast it to do so, and you can use octal numbers too. The same casting rules apply, but in practice you don't have to worry too much about the casting because failing to cast a value that won't fit will always generate an error message. An int is a 32-bit signed integer and can be initialized with a base 10 literal number. You can also declare an integer literal constant as a hexadecimal number. And you don't have to worry about casting if the number is large enough to be negative because the Java default is to convert the literal into an int, and it can be directly assigned to the variable. The same goes for octal digits. No casting is necessary. A long is also a signed integer. It's 64 bits long. You can declare a long constant as a base 10 number. The compiler automatically converts these into int types, and an int is smaller than a long, so you can assign these directly to a long without any problem. But if the number is too large to be declared as an int, you'll need to tell the compiler that you want a long by putting an L at the end of it. This number is compiled into a long constant value because it ends with an L. Java doesn't care whether you use an uppercase or lowercase l, but I suggest you use an uppercase because it can be deceiving. The first number here is an int value of 8,921. The second is a long value of 897. You can also specify long values as hexadecimal digits. And with octal digits. No casting is ever necessary. Any integer value that will fit anywhere will fit into a long. Any numeric declaration ending with the letter F is a real number. It's not necessary to have a decimal point or an exponent in the number for it to be a float, but the F is necessary. The letter F can be upper or lower case, but it must be there for the constant to be a float. You can include a decimal point if you want. You can use the letter E, upper or lower case, to specify an exponent. A double value can be declared by being tagged with the letter D. If you include a decimal point, you can either include or leave off the D on the end because a real number declaration always defaults to a double, not to a float. These are all the literal declarations, except one. I skipped the char data type for now, but I do explain that one in the next lesson.